And again, functions defined by integrals. Here, number 11, they give us the big F function is defined as from 1 to 2x of f of t dt. Graph of f is on the closed interval 0 to 6 as shown. And each of the areas A and B have 1.3 as their areas. We can see that it's a line segment from here on out, so we can of course calculate the areas of these triangles when necessary. We'll deal with that in a minute. So first of all, if we want big F at 0, that means we're going to go from, in our integral, from 1 to 0, 1 to 0 that is, of f of t dt. Again, we're putting a 0 in for x, so that makes our upper limit 0. So if we want the area from 1 to 0, if we go from 1 over to 0, the area we know is 1.3, they told us, but we're going from right to left, so therefore it would be negative 1.3, should have been your answer for that one. And then your big F at 1 is going to be from 1 to 2 of f of t dt. And if we go from 1 to 2 of f of t dt, we got another 1.3, but it's below the x-axis. We're going left to right this time, but it's below the x-axis, so it would also be negative 1.3. Should have been those two. Questions? All right. The next part here says determine the derivative of big F, and we know that we have an integral defined function, so the integral of that function is the integrand evaluated at the upper limit times the derivative of the upper limit. So ultimately the integrand evaluated at the upper limit would be f of 2x times the derivative of the upper limit would be 2. So that should be our derivative of our big F function. Again, fundamental theorem. Integrand evaluated at the upper limit multiplied by the derivative of the upper limit. Simple as that. Questions on finding the derivative of big F? Alright, then the next part says determine the critical numbers of big F on the interval 0 to 3. Well, got a closed interval here, so 0 and 3 are two of the critical numbers. Okay. Alright, and the rest are when the derivative equals 0 or when the derivative does not exist. Well, we can see the picture of the derivative here is related to this function. Okay. This is f. Our derivative is f of 2x times 2. So the derivative is related here. We ultimately are going to need to figure out where this equals 0. We can see that this is this f function is going to be continuous. There's not going to be anywhere that it doesn't exist. But we also know that the critical numbers are going to come from when the derivative equals 0. So the question is, does this equal 0 anywhere? Well, 2 obviously doesn't equal 0, but f of 2x equaling 0, that could happen. And ultimately that would happen. We can see that the f function equals 0 here and here. True? So the question is, what would we need to put in for x in order to get 0? Well, it equals 0 at 1. True? So that means what would x have to be in order to make this sentence equal 0? I'd need to have this be a 1 in the parentheses, wouldn't it? So therefore x would have to be half. Okay. So if x were a half, then on the left-hand side I'd have f of 1. And what is f of 1? We can see f of 1 is what? F of 1 is 0. What about this one? We'd have another 0 here. And what would we have to put in the parentheses to get have this read f of 4? It would have to be a 2. So there would be other critical numbers from that part would be 1/2 and 2. Again, we need the derivative to equal 0. This being the derivative, in order to make this sentence equal to 0, we need to have a 1 in the parentheses or a 4 in the parentheses as shown by the graph above. Questions so far? Alright, and then part D here says determine which of the critical numbers big F corresponds to a relative maximum value of big F on the interval 0 to 3. Okay. And keep in mind that one thing that people might be thrown off, they might not get this second one, by the way, because you might say, oh, 4 is over here, that's not in the interval. Okay. But is the actual critical number in the interval? That comes from that 4? You bet. So make sure you try it out. If we had gotten that 4 and then ended up being, you know, like if it was over here at 6 and ended up being whatever it was, let's say it was at 8, just for argument's sake, and the actual critical number was 4, then would we need it? No. Okay. So this critical number is definitely between 0 and 3, so we definitely need to find it, and it comes from the fact that there's a 0 here at 4 for that f function. Okay. Alright, so let's decide which, do we have maximum or minimum at these points? Okay. Well, we know again that we have our number line here, we have a 0, a half, we got a 2, and a 3. And if we check out our derivative here, do our first derivative test, see what we got. So we know that at 0, okay, our derivative, if I were to put a 0 in here, okay, our derivative would be 2 times f of 0. F of 0 is 2, isn't it? So the value at 0 itself would be 4. And let's just say, for argument's sake, I put something between these two in here, between 0 and a half. If I put in a quarter, let's say, I'd get f of 1/2 here. And what is f of 1/2? F of 1/2 is positive, isn't it? Times 2, that'd still be positive. So it's positive between those two. How about between a half and 2? Like say 1, for instance. If I were to put a 1 in here, I'd get f of 2. F of 2 we can see is negative 2. Negative 2 times 2 is negative. And then between 2 and 3, between 2 and 3, like if I put, let's say 2.5 in there, I'd get 5 in here in the parentheses if I did 2.5. So that would mean I'd have f of 5. F of 5 we can see is positive. So therefore we'd have positive here. So bottom line here to answer the question then is which one of these corresponds to a relative maximum? Well, we can see that we're going from 0 to 1/2. We're increasing. It's positive. Okay, and then when we get past a half, it's decreasing. So what does that tell us about a half here? A half, there's a maximum, isn't there? So at x equals 1/2 would be one answer. What about this one? Wouldn't this have to be a local maximum also? Remember, the endpoints are included here. Once we get to 2, we go back to increasing, and we increase all the way until we get to 3. So wouldn't 3 be a maximum in its area? So it would be something like this. We may, you know, be a point like that, maybe something like that. Okay. So 1/2 and 3 would correspond to local maximums. Questions on that analysis? And the opposite question here in part E, well, we can see that, that 0 and 2 are going to be the minimums, because we're increasing away from 0 here. If we're at 0, we're increasing as we go away from it. So that situation would be maybe something like this, where 0 is our point on the left-hand endpoint. And then, of course, 2 is where it changes from negative to positive, the derivative. So therefore, 2 would be another answer here for the minimums for this one. Questions on anything on parts A through E before we carry on to the next part? Okay, well, we had one more worksheet here to deal with here. That's number 3. So let's see if we can answer the similar questions here on this one. This one is defined from 2 to x of f of t dt. We have a negative 2 to 6, including, notice, 2 line segments in a quarter circle here. And so we're going to determine big F of 0. And again, big F is defined by the area. And so if we go f of 0, that means we're going from 2 to 0. So that means that we're dealing with this triangle right here. That goes from 0 to 2. It's a 2 by 2 triangle. So therefore its area would be 2. And it's going right to left, and it's above. So right to left and above would be negative. So ultimately your f of 0 would be, should have gotten negative 2 for that one. Your 4 here is going from 2 to 4. That's the quarter circle. It's a quarter circle that has a radius of 2. So that means it would be pi times 2 squared. Be 4 pi would be the radius of, or would be the area of the circle, but it's only a quarter. So therefore it would be pi. So your f of 4 should have been pi. part B here. It says determine the interval where big F is increasing. Alright, so big F increasing would be ultimately when big F's derivative is positive. True? And keep in mind the derivative of big F here is f of x. Okay. We don't have any chain rule issue here because the upper limit is just x, so it's just the derivative, it's just the integrand evaluated at the upper limit. Okay. So this is the derivative of big F, f of x. So this is a picture of the derivative. So when is it positive? It's positive from 0 to 4, and then again from 4 to 6. Okay. So it would be increasing on 0 to 4, and on 4 to 6. I don't ever put them included because ultimately, in my opinion, it's stationary at those points where it changes, where they have zeros for the derivative. Okay? So I do not include them. On the AP test, if you include them, as I've mentioned before, they'll be okay with you including them because some books do include them, some don't. Okay? So it's up to you whether you include them or not. I'd prefer you not, just so that we're all consistent with each other, so we all get the same answer. Alright, so justify your answer. This is when it's increasing, because this is when the derivative is positive. Alright. Part C says find the critical numbers of big F and determine where each corresponds to a relative maximum, minimum, or neither. And justify. So we know that our critical numbers, again, are going to be when the derivative equals 0. And also endpoints, because notice the endpoints here are included. So that means we're going to go -2 and 6. They're going to be on our number line. And in between, where does the derivative equal 0? Well, derivatives equal 0 at 0 and at 4. So 0 and 4. And if we do our test between -2 and 0, the derivative is negative. And again, we can see that right from the picture. Between 0 and 4, the derivative is positive. And between 4 and 6, the derivative is positive. So based on that analysis, what could be said about -2? Let's start with that critical number. It's decreasing away from it, right? Decreasing right, so that would be a maximum. Remember, we're at -2 and it's decreasing as we move to the right. Okay. So -2 would be a max. 0 would be we're decreasing to get to it. Increasing away from it, so it'll be a minimum. How about 4? Increasing to the right of it, decreasing or increasing again to the increasing to the left, increasing to the right, I should say. So that's not either, is it? So that would be a flat spot. So it would be an either. And x equals 6 would be we're increasing to get to 6, so that would be a neither. Maximum, minimum, or neither were our 3 choices. I can spell it right, that'd be helpful. Yeah. And x equals 6, if we're increasing to get to 6, we would have a maximum there. Questions on any of that analysis? Alright, how about absolute extreme values for big F and where they occur? So absolute extremes are going to be just critical numbers. Okay, and ultimately, anytime we're looking for absolute extremes, when we have a closed interval, we should always use the candidate test. Okay, so ultimately our answers are f of -2, f of 0, f of 4, and f of 6. And if we can determine the values of the 4 of those, then we can see which one's biggest and which one's smallest. And those are going to be our absolute extremes. Okay, so we're just going to find all the candidates and find the values of y at those candidates. And we'll decide which one's the biggest, which one's the smallest. Alright, well we know f of 0 is -2. We already did that one earlier. We know f of 4 is pi. We already did that one earlier, so we got those 2 done. What about f of -2? Okay, f of -2, we'd go -2 to get to here, okay. And then another 2, but going right to left and being below it to make it positive. So this would be -2, this would be +2, so ultimately that answer would be 0. And then from going from 4 to 6, I have a 2 by 4 triangle. So that would be area 4, and it's positive. So wouldn't this be pi plus 4 then? We know at 4 we're already at pi. Okay. We're going from 2 to 4 here. So if I want f of 6, going from 2 over to 6. So we know that's pi, and that would be 4. So therefore it would be pi plus 4. So the absolute maximum here would be this one. Okay, remember they've asked us for a value. So this would not be okay to leave this as the answer. So we'd say the min value is what? Negative 2. And that'd be add x equals 0. That's the way we should state it. And then the max value is pi plus 4. That would occur at x equals 6. Questions on that one? Alright, then letter E, find the x-coordinate of the inflection points of big F. Inflection points are going to be when we have the second derivative of big F, which is when we'd have the derivative of little f then. And we know that inflection points occur when the second derivative is equal to 0 or does not exist. Okay. So those are candidates. So looking at our picture, where does the derivative equal 0 or not exist? Well, looks like we have a corner at 2 would be a non-exist. Another corner at 4. So the candidates would be 2 and 4. And the question is, are those both inflection points, or is one of them, or are neither? Okay, bottom line here is that our derivative of our picture at 2 changes from positive to negative. So that would be a yes. And then what happens at 4? It changes from negative to positive. So that would be a yes as well. So both of those would qualify as inflection points because that's where the derivative of the derivative. Okay, keep in mind we're looking at a derivative at the derivative here. Okay, so we want to know when does the derivative of the derivative equal 0 and change from positive to negative. Okay, so here would be 1 because the derivative changes from positive to negative. Here would be no because the derivative changes from negative back to positive. So those would be our two inflection points, 2 and 4. And then F says determine the intervals on which big F would be concave down. And again, big F would be concave down anytime that the derivative of little f is negative. So that would be between what? Between 2 and 4. The derivative of our derivative. Keep in mind this is the derivative. The derivative would be negative between 2 and 4. So, and there's another case where we use brackets or parentheses. I would always use parentheses. And some books use brackets. So brackets are okay on the AP test, but I would use parentheses if I were you. Alright, questions on that one? Alright, let's see how we did here with number 2 then. We got, similarly, we got this h function that's defined by the f, and notice that the upper limit here is x plus 2 instead of just x. And it says that we're on a closed interval, negative 5 to 5, and we just have line segments. And we want the domain of big H here. Okay, so the domain of big H then is going to be what numbers can we put in here for x? Okay. If we can put in a negative 5 to 5, okay. Question is that going to work? If we put in a negative 5 into this integral, we're going to have from 0 to negative 3. True? Remember, this negative 5 to 5 is the domain for f, keep in mind. Right? So the question is it okay to put a negative 5 into this integral? If I put a negative 5 in here, I'm going to get negative 3 as my upper limit. Am I going to be able to find an answer for 0 to negative 3? Sure. Okay. 0 to negative 3, I can see it right here, can I? What about a 5? Can I put a 5 in here? If I put a 5 in there, that's going to give me a 7, but that's not okay, is it? No. So what's the biggest I can go in terms of x here? Wouldn't 3 be the biggest I can go? Okay. If I put anything bigger than 3 into the h function, I'll get something outside that window. And then over here, wouldn't this be a negative 7? I could put a negative 7 in and I would be okay, wouldn't I? I could get an answer for negative 7. Because negative 7 would put me to negative 5 for the upper limit. So that would be my domain for h in this case. Alright, what about the range for h? Ultimately, they're asking us in disguise here, what are the absolute maximum and minimum for h then, aren't they? If I knew the absolute maximum and minimum, I could get the range then, couldn't I? Just like we did up here. Wouldn't the range on this one be from negative 2 to 5 plus 4? Those would be the absolute max and min on those intervals. Okay. Alright, well, let's see if we can figure it out then. We know that for this h function, that our endpoints for h are negative 7 and 3. So those are our candidates. We also know that we're going to have other candidates when the derivative equals 0, keeping in mind that this is a picture of the derivative, or it's at least related to it. Okay, and so we want to know what's going to give us, if this is 0, we can see that the derivative equals 0 at 0. True? Alright. But the question is it h of 0 then? Yeah, it'd be h of negative 2 then, wouldn't it? Because we're, again, everything's translated 2 to the right. Okay. Alright, so let's see if we can figure out some values here. If we put in negative 7 into our function, we'd have the area from 0 to negative 5. So if I go from 0 over to negative 5, that's going to be a rectangle that makes 6, and a triangle that's 2 by 2, which would be 1/2 times 2 times 2 is 2. So it would be 6 and 2, that would make 8. But we're going left to right, so that would make a negative 8 then. Or right to left, I should say. And it's above. So h of negative 7 would equal negative 8. h of 3, we're going from, we're going from 0 to 5. So 0 to 5 would give us 4 here, and then a half here. So it'll be 4.5, but it would also be a negative as well. Alright, and then how about h of negative 2? If I do h of negative 2 here, if I put a negative 2 in there, it's going to give me the area from 0 to 0, which is what? Yeah, which is 0. Okay. So, the question is, and if you just kind of think about it from a little different standpoint before we actually come up with our answer, is it a fact then that that 0 is going to be the biggest I can get? Could I never get anything positive out of this integral? Well, let's think about it. If I put a negative 7 in there, I'm going to get, we already said it's going to give us the area from negative 0 to negative 5. Okay, it's going to give us negative. If I put a negative 6, it's going to be the area from 0 to negative 4, which will still be negative. Okay, the next one will be 0 to negative 3, still negative, still negative, still negative. And then once we get to this point, okay, anything that we do that's going to involve these numbers is going to be below the x-axis going right. So it's going to be, again, all negatives. So ultimately, what do we got going on at f of negative 2? We have a maximum, and the maximum value is actually what? Is 0.
I don't feel good.
Alright, so bottom line here is our minimum value, our absolute minimum would be negative 8, and our absolute maximum would be what? Would be 0. Okay. So ultimately, we have negative 8 to 0 would be our range. And then in part C, determine the x-coordinate of the relative extrema of h and justify your answers. So the relative extrema, we'd have minimum negative 8 at x equals negative 7. And we'd have a minimum of negative 4.5 at x equals 3. And we'd have a max of 0 at x equals negative 2. We're doing it. Okay. Questions on part C? Alright. One more on here. Let's check it out. See how we did on this one. We got the graph of the function. The graph below is the function f prime, so we have a derivative graph. And we're going from 0 to 17. We've got 2 semicircles, 1 line segment, horizontal tangents at 2 and 8. Vertical tangent is at x equals 4. Okay. And ultimately here we want to know on what intervals is f increasing. So we have a picture of f's derivative. So f would be increasing when f's derivative is what? It's positive. So that means from 0 to 4 would be one such interval. And then also from 12 to 17. And how would we justify that? Because here, these are the intervals when f prime is what? It's positive. So that's all we really need to say. We just need to say f prime of x is positive. Okay, how about part B? For what values of x does f of x have a relative minimum value? Well, the minimum value would be when the derivative changes from negative to positive. So wouldn't it be right here at 12? And again, the simple answer is because f prime changes from negative to positive. Don't need to write a novel, just write y. We know that's true because that's where f prime changes from negative to positive. Alright. Part C asks for what intervals between 0 and 17 is the graph of f concave up. So concave up would mean when the derivative of the derivative is positive. So that would be from 0 to 2, the derivative of this picture would be positive, wouldn't it? So it would be 0 to 2 would be one such interval. Also from 8 to 12. And then from 12 to 17. And justify it because this is when the second derivative is positive. Questions on concavity analysis? Alright, how about when is the second derivative undefined? Second derivative would be undefined anywhere that the derivative of this doesn't exist. So that would be at 4 and at 12. Why doesn't the second derivative, the derivative of this picture doesn't exist here? Because it's a vertical tangent. Doesn't exist here because it's a corner. Right?
Yeah, it's kind of a dumb question, but what exactly is
Didn't even
it?
ask you yet, I didn't know that.
I don't know. I just feel like what's a vertical tangent?
That is pretty dumb.
It's a horizontal tangent.
I know what it is, but
Well, ultimately, I mean, as we approach 4 here, what are the slopes like as we approach 4?
zero.
No.
No.
Oh,
Yeah.
Infinite negative.
It'd be infinitely negative, if you will, infinitely big negative. And as we approach from this side, what are the slopes are getting bigger, approaching what?
Oh, infinite.
Approaching infinity. If I drew a tangent line here, it would be what? It would be vertical, wouldn't it? So at that one spot, there's no derivative there because that's a vertical tangent. What do you got that? So, not a dumb question. And then again, ultimately, this one's a corner because the derivative on the left and the derivative on the right are not the same. Alright. Part E, identify all the x coordinates of all the inflection points of f. All inflection points are, really, these are the only 2 candidates, aren't they? Or not? Gotta be careful. Those are where the derivative doesn't exist, but where else would we have candidates where the second derivative is equal to 0? So wouldn't 2 and 8 also be candidates? Okay. And at 2, you know, really this right here tells us the answer, doesn't it? Because at 2 we change from positive slope to negative slope. So that means that 2 would be an inflection point. Because the slope of our derivative changed from positive to negative. What about at 4 itself? Would 4 be an inflection point? Remember, the slope in front of it is negative. The slope behind it is negative also, isn't it? So even though the derivative doesn't, or the second derivative doesn't exist, it doesn't change signs, if you will. So that's not. What about 8? Goes from negative slope to positive slope, so 8 would be 1, wouldn't it? And what about 12? Left side's positive slope, right side's positive slope, so therefore that's not either. So only 8, 2, and 8 would be our inflection points. And f says for what value of x does big F, or does little f here, which is the function here, reach its absolute maximum value. Yeah, absolute maximum value. Again, those are going to occur at our critical points. And keep in mind that 0 and 17 are candidates. So if we did f of 0, f of 17, and our derivative is equal to 0 at 4 and at 12. So those ultimately would be our 4 candidates for when we could possibly have an absolute maximum. Right? And if we do f of 0, keeping in mind that we're not given an actual integral function here, so we could ultimately, I guess it really doesn't matter what we let our lower limit be here, since we have 0 as our starting limit. Okay, ultimately, if we start at 0, what are we doing? We're accumulating positive area here, aren't we? Okay. And so if we accumulate positive area, that's going to be a 2 radius, half circle. So 2 pi would be our area. So f of 4 would be 2 pi. We can consider f of 0 just to be 0. Call that our starting point. F of 12, we're going to put in 4 to 8. That's going to be a 4 radius circle, so it's going to be 16 pi, it'd be 8 pi. So it'd be minus 8 pi, it'd be negative 6 pi we're at when we get to 12. Because we were at 2 pi, we accumulated positive 2 pi, and then we accumulated negative 8 pi because of the bottom circle. And then going from 12 to 17, that's a 5 by 2 triangle. So the area would be 1/2 times 2 times 5, which would be 5. So this would be negative 6 pi plus 5 would be our answer for 17. And bottom line is which of these is the max? Well, negative 6 pi is definitely, adding 5 to it's not going to make it positive, so that's definitely smaller than the only positive one we have, which ultimately would be 2 pi. 2 pi would be the value, the location would be x equals 4. And finally, if f of 4 is 3, we want to find f of 12. Okay. So we know that f of 4 is 3. Keeping in mind then that we went from 4 to 12 of our f prime function dx. Okay, we'd accumulate some area. We were at 4, we're already at the value of 3. Okay, and we want to know where we're at when we're at 12. So if we just did the area under our curve from 4 to 12, and we add that to our initial value, which is 3, we'll be good to go. So our final answer then would be this, which ultimately the area from 4 to 12 we just said was negative 8 pi. So it would be 3 minus 8 pi would be our answer for that part.
Wait, why'd you put 3 plus 3?
It's going to be wherever we were plus the change. Think of it like velocity. If this was a velocity curve, this would be the displacement, wouldn't it? And this could certainly be negative if the area is below the curve, which it is in this case. So it's always just going to be whatever our initial value plus the change. The change could be negative, of course, which it was in this case. Had that circle been above the x-axis, then it would have been 3 plus something. All right, any questions on number 3? All right, so again, these modules that I've given you here are of high importance in that these are very much like AP questions. They're very good practice questions to study from. All right, so let's go ahead and move on to our last module packet that I gave you, which is the fundamental theorem of calculus 1. Got some similar problems in here that we were asked to do.